acetylides can react with carbonyl groups. Like so, here's the outline of the reaction. It does not necessarily have to be acetylide. A nucleophile can attack the backside of this carbonyl group. It's a polarized bond. This carbon has a partial positive, the oxygen has a partial negative. A bond is formed, one of the bonds breaks on the oxygen, it has a negative charge. An acid or water, something that can donate a proton, will give a proton to this oxygen, leaving the nucleophile bonded to the carbon and an oxygen. In this case, we're looking at creating an alkyne with an alcohol group. So our nucleophile is going to be acetylide. Acetylide undergoes this nucleophilic reaction. In this case, it's a ketone. There are two carbon groups, but it doesn't necessarily have to be that. It reacts with the backside. An electron pair goes to the oxygen. We're left with this triple bond to the carbon, two other carbon groups, an oxygen. This has a minus charge. An acid comes and gives a proton to the oxygen, and we're left with this alcohol of degree 3 with the alkyne group. Of course, it does not necessarily have to be a ketone. It can be an aldehyde or a formaldehyde, and that's what these other two reactions are. There is literally no distinguishing, there's no difference between them. The same reaction takes place. It's a substitution, not a substitution, a nucleophilic reaction. So a substitution reaction is also a nucleophile reaction, but this is not a substitution. Attacks the backside, same thing happens. Electrons go to the oxygen. The only difference is instead of two carbons being here, there is just one, there's a hydrogen. And the example with the formaldehyde, it's the same, except there are two hydrogens here. So this will be a second degree alcohol, and this will be a primary alcohol.